So let's get started with the topic for today. So this is the agenda. We'll talk about key concepts. I have borrowed the key concepts from Daniel. Daniel is sitting here. So Daniel Nature, his book about performance tuning. So I have borrowed those concepts from there. We'll discuss about the common challenges in MySQL performance and then the performance tuning methodology. All these concepts and methodology comes from his book. So it can be applicable for any MySQL instance, be it deployed on-premises or on cloud or maybe OCI or HeatWave. Any MySQL instance that you run, these concepts can be applicable to those instances or those deployments. And then we look at what is monitoring, what is observability, and what do we have in OCI for observability and management for MySQL. And we'll also quickly look at what in general do we have for monitoring MySQL from an on-premises database perspective, both from an cloud angle as well as from an on-premises deployment for monitoring tools. So with that, we'll get started with the key concepts. So the key idea here is like, why am I actually looking at my database? Because I am actually running a slow query. And the question that I have is like, the burning question is like, my queries are slow. What is that I can do? This is the most common question that I get. And then what can I do to make sure that my queries are running faster? So it could be due to a lot of reasons. Basically, it depends upon the query, the schema that you're looking at, the access patterns that the query is driven by, and then maybe the connection behavior, the underlying operating system, and the application itself. So there are multiple ways to look at this problem. So the question is like, my queries are slow, how can I run faster, or how can I make it faster? So what is performance in MySQL? So it's all about a key metric called as response time. So what is response time and why is it important? Typically, we don't think about response time in terms of how many rows are getting retrieved or how many rows are you kind of going to the database and fetching the number of rows that the table has. It basically boils down to the fact that, okay, am I having an impatient response? Or am I getting impatient because of the data that is being retrieved from the database and takes a longer time to retrieve? So essentially, query response time is the only performance metric that would reflect the end user experience directly. And that's why it's very important to have an understanding about what is query response time. Now let's look at what is query response time. It can be divided into multiple sections. It's basically the client to server transmission time. So the time it takes for the query to go to the database, fetch the rows, and maybe in between it actually does some query parsing and optimization, wherein it talks to the optimizer, understands the access patterns, brings back the right path to get to the data, and then it has to execute the code. And then also might be doing some work on the CPU or maybe some work on the disk, depending upon what is needed. If the data is not there in the memory, it does some disk I/O, and then you will get the results back. And the amount of time that it takes for all this is the query response time, and you can break it down into multiple sections as well. So this is essentially the key concept behind the response time. Now, what are the common challenges? Now that we know that we have a problem with query being slow, we understand the key metric is the response time and what are the common challenges that we get. So we can divide these challenges into multiple facets or maybe multiple buckets, I would say. It could be because you are running a complex query. The query is really complex, and then we might have to look at the query itself. And maybe you're having a bad indexing strategy. So your indexes that you have built on these tables are not good because of maybe poor selectivity patterns or something of that sort. And then over a period of time, your data has grown and you have huge data pattern issues or data access issues that you need to deal with. And you also might end up having resource contention issues. Maybe you have high concurrency related issues, locking, latching, and also maybe the resources from an operating system perspective is also limited. So you can categorize them into common challenges in this fashion. And then if I have these challenges identified, then how do I make MySQL go faster? So the question is like, I have a slow query. I have seen that the response time is pretty bad, and then I have bucketized them into multiple ways that I could see them as a challenge. Now, how do I make this go faster? So to make MySQL do more work, you need to have two choices, or you have basically two options to deal with this problem. You can decrease the response time, or you can increase the load capacity. So what do we mean by decreasing the response time? You can optimize how fast each query kind of runs. That's the goal. And then it involves query tuning. It also involves things like coming up with the right indexing strategy, or maybe schema tuning or design of the application itself. Now, the second option is to increase the load capacity. So the moment you talk about load capacity, you might think, okay, I can throw in more hardware and then increase the load capacity. It's not just that. It's not about CPU time. It also boils down to your application design, how you're connecting to the database, and also it also boils down to the amount of time that you spend retrieving the data from the disk. So essentially, it's all not just CPU time, but it also is about wait time within the database and where are you waiting. And you might also look at alternatives like using RAID replicas, or maybe scaling to a better hardware, or maybe changing to a new architectural pattern, depending upon if you've failed all these scenarios. Like you've touched your query, you've tried your indexing strategy, you've tried to improve your concurrency by improving the query itself, or maybe improving the efficiency of the query, and then finally you kind of used other patterns like RAID replicas or maybe a better hardware and things like that. So that's the goal here, and we'll look at when to use what and how do we kind of get to that using tools. So we'll look at the performance tuning methodology in detail, looking at the two options that we provided earlier. So one is like you can improve the query response time with the proper query optimization. So query optimization is basically something that you go do on an ongoing basis. It's not just a one-time job or something. Okay, I'm done with this query, and then okay, this is not going to go slow down again, right? It's something that you need to put in a lot of effort, a lot of time goes into it, and then you would need to actually do a constant refinement of the same query depending upon the data that has been involved and things like that. So you can do a direct query optimization wherein you actually tune the SQL itself. So you can look at the structures or maybe the table structure, maybe the filters that you applied, the where clause, the joins, and then also finally look at the indexes so that you are using a proper indexing strategy. The next thing is about indirect query optimization. It's basically looking at modifying the data access pattern itself. So you have done everything right. Your indexing strategy is looking good. You have tried to tune your query. You have understood what the query is trying to do. Maybe you have to deal with data growth and something not related to the query, but then indirectly related to the query. So that's where we have this indirect query optimization. So now let's go one by one and see what we can do for direct query optimizations, and then what tools do we have. The common tools that we have is the query analysis methodology itself. So what does it mean by query analysis? You need to understand how to actually interpret the query itself, right? What does the query do when you actually throw it into the database? How does it interact with the optimizer? And what metrics can I read, and how can I read those metrics? And for that, I need something like an explain plan or an explain analyze, which tells me what the query is trying to do or what the optimizer is trying to do. So there are two different things here. What is the difference between explain and explain analyze? Can anyone?
I think I learned that this morning. Okay, let's see if this is right. Explain just kind of gives you general cost estimates, whereas explain analyze actually executes the query.
Perfect. Absolutely, yes. So explain is basically giving you an understanding about what the optimizer actually thinks, but explain analyze is like what the optimizer actually does. So that's how interpret explain and explain analyze, and it's important to understand an explain plan and how do we use explain and explain analyze. And then you can look at indexes. You can add indexes, or maybe you can drop indexes depending upon whether it is really required or not. But then you basically play around with all this. And then you have specialized tools like, these are all access patterns. Maybe you are an advanced user and if you want to look at other patterns like range optimization, index merge optimization. These are all good to have things or good to know things if you understand the query better. But then in general, you can always start with the common tools, and most likely you would end up having a solution if you look at that. And if you're an expert, then you would be encouraged to look at these advanced features, which helps you optimize the query further. But an understanding of them would allow you to rewrite the query, or maybe the optimizer might rewrite itself depending upon all these advanced capabilities that you have. So with that tool, now let's see what can I do for query analysis. So the analysis part is to understand what actually what has been run, and how do we kind of make sure that we understand the slowness in the query itself. So it involves certain metrics. So query metrics, there are 9 key metrics or 9 essential metrics that you need to be aware of. Query time, which is basically the amount of time the query itself takes to bring the data back to you. Locking, if you have locking issues, how much time am I spending on locks? How many rows did I examine? How many rows did I was sent or returned to the client when I actually asked for maybe 1,000,000 rows? Did I get 1,000,000 rows response back? And how many rows did I actually look up in terms of changing? If I have to do inserts or updates or deletes, how many rows did I actually look up, and then how many did I change? Select scan basically deals with full table scan. Essentially, you don't have an index and you end up scanning the entire rows within that table would be what you do when you talk about full table scans. And a select full join is wherein you have a join which has no index, but you are doing a join with no index. So that's the metric that you would look at. And more importantly, you would also want to have your temp tables or maybe sorting to be done on the memory itself and not onto the disk. Any sorting or any temp operations that you do on the disk is going to be very slow, and that's very important to have an understanding about. And then you have the query count, which is the number of times the query got executed. Now, how do I get all these metrics? All these metrics can be made available by looking at the performance schema, or maybe all these tools that MySQL exposes. We'll look at that later, but then you also have the metadata in the form of explain plan or the explain analyze, which tells you the table access structure, access patterns, indexes, and so on and so forth. And finally, you also need to know, like, what are you trying to do, right? Why am I writing this query? What is this application trying to do? If it is a complex logic, and is it really needed for you to write in this fashion? Can I retrieve the data in a much more efficient way by rewriting the query itself? And that's where the explain kind of comes handy. So that being understood, we can now look at, this is an example of how the explain and explain analyze would look like. So if I have a simple query, explain would basically tell you what the optimizer thinks, and then explain analyze would really execute the query and then give you what the optimizer actually has done. So you can get varied answers depending upon if the optimizer went wrong, if your statistics are wrong, if you have not collected proper statistics, or if you have an histogram related issue or something of that sort, then you might get a different answer from the optimizer than the explain when you do an explain analyze. Now that we have done with the direct query optimization, we look at what is indirect query optimization. So we said that, okay, the first thing to do is like to try to understand what the query does, maybe look at explain plan, then see if you can add more indexes or if an index should be dropped or whatsoever. But then if you have tuned that, and if you reach a saturation point wherein beyond a certain point, your data kind of increase over a period of time and you have issues with the same SQL that was running fine earlier. Maybe this is where the indexes got poor selectivity. The selectivity of that index was lost, and then you had more data that came into the database over a period of time and then has maybe clustering issues. The data got spread across the table and the index is not behaving well. Maybe a good idea to reconstruct the index or maybe retune the indexing strategy and things like that. And you have done that too. You have poor performance despite retuning the index, and that's when you have to look for indirect optimization techniques, like maybe look for the join orders or the join patterns. In general, MySQL is smart enough to come up with join orders or patterns on its own, which is using the advanced features, but then you might also want to look up and see if you want to rewrite the join order or maybe give some extra hints so that the proper index is being taken when you do the proper joins. And the key thing is, like, if no index has been used, you would end up having something which is having a full join as well. Now, even with indexes, you could see that performance tuning or the performance of the database would suffer if they don't match a specific row. So that's when you need to look at, am I really needing to run this particular query or not? Or should I actually look at alternatives like, okay, should I avoid a particular column? Do I need to do select star or just select ID? Or maybe can I limit the result set by using the limit clause within the query itself? Can I avoid unnecessary sorting? So sorting, as we discussed earlier, could be a resource intensive operation. So can I avoid sorting by some fashion or the other? and maybe it's time for you to remove or archive your old data by using techniques like archiving, or maybe partitioning is another option that you could do. And especially it's important for data like log tables or audit trails or time series data, wherein you might have to remove them or move them periodically to secondary storages. Now we have done with direct query optimization, then we have done with indirect query optimization. Now we need to look at increasing the load capacity. So increasing the load capacity in general, as I said before, people think about throwing in hardware. Can I increase more capacity by throwing in more CPU cores or more memory? But then it happens, computer science kind of tells us that you cannot actually scale, or you cannot use 100% of your CPU resources. The more you load the system, the more chaotic it behaves, and you would see a lot of mutex contention or locks and latches and all that whatnot. It's an operating system behavior. Ultimately, it's a program that runs on top of the operating system, and you're kind of, loading the operating system to do more work, and it results in wild fluctuations that you need to be thinking about. So that's when we actually think about, can I tune the load itself? Can I look at my connections? Am I doing a lot of connections, or maybe I'm a Java programmer and I have not used connection, wherein I have introduced connection leakages. If I have not closed the connections properly, maybe I have tried to do a lot of rapid retries, and is it a right strategy or not? So that's when you would actually end up tuning the load itself, and maybe offload or distribute to options like maybe read replicas, or maybe partitioning your data. So archiving is one strategy, or if you want to retain the data, you can actually partition the data by using partitioning techniques. And one example that I would like to give here is like the handling of write surges with grace. If you have like a database that was down for a specific period of time, and your application tries to write or has a lot of writes to do, and if you don't actually segregate them or do them in a batch processing, you end up having a lot of queries that is going into the database at the same point in time, and then that improves, or that kind of degrades the performance rather than improving the performance. So you need to look at how actually you're loading the database as such. A key metric to understand from a concurrency perspective is the query load. Query load is the total query time over wall clock time. So wall clock time is the time that you would see for that particular observation or your observation period. For example, if you have a query that took maybe 500 seconds over a 300 seconds wall clock time, the load is 1.67. So why did it take that much time? Because it has to do CPU, it has to do disk IO and all that, and that's how you would see the query time is kind of lagging behind, or it actually tells you the kind of concurrency that you have on the system. If it is less than 1, then you would see it runs occasionally and there is no concurrency at all. And if it is greater than 1, you would see there is a concurrency. Essentially, you would see of the order of how many concurrent sessions are getting connected to the database and how many queries are getting fired for that particular connection. And mostly if you see a query load greater than 10, it indicates that you are bombarding the system with a lot of connections, and then the concurrency kind of suffers. You can do the same thing for the database itself. You can look at the total database query time over wall clock time, which would give you the total active sessions for that particular database overall in general. So this is something that we need to be aware of. We need to understand how many average active sessions do you have for the DBs that you're connected. So as I said, we cannot scale this infinitely. So what can I do to make sure that I monitor them? I have tools like vmstat or the host commands that I can use, or performance schema. Specifically look for resource contention like latches or maybe mutex level data that I might be interested in. And then I can also look at the information schema, slow query logs. All those have detailed information regarding what can I do beyond query tuning. What can I look at? What can I do if I have to, go and look for arenas or situations where I am running out of ideas about query tuning. So now let's look into that's theory. Now with that theory, we'll look into observability and monitoring tools for MySQL. So we have a flexible model here. So we had a session on Enterprise Manager maybe an hour ago. So we give you choice. You can either use Enterprise Manager or the observability and management cloud platform within OCI. So we have services like database management and ops insights. We are also trying to offer logging analytics where you can read the slow query logs and then get analytics out of it. So it's an integrated platform. You can also integrate that with the open telemetry. We had a session on open telemetry as well. So you can send the data over to the APM tool, which is there in OCI, and then integrate that with other capabilities like logging and then ops insights as well. On the other hand, Enterprise Manager is an on-premises tool. The same methodology that we discussed earlier can be applicable for monitoring MySQL databases on-premises using the Enterprise Manager tool. So in this talk, we are going to focus on how we can use observability tools within cloud. So this is the observability and management platform within Oracle Cloud. You have capabilities for monitoring. You start with monitoring and then you end up having observability. So we'll have a discussion around what is the difference between monitoring and observability. So you have capabilities for AI ops and analytics. You can do diagnostics tuning. So the key core fundamental to that is metrics, events, logs, traces, and SQL. So in general, people talk about metrics, events, logs, and traces, and we've added SQL to it because that's an important metric as well. We are monitoring MySQL, so we need to have SQL added to it as well. And this platform essentially supports deployments in Oracle Cloud, Azure, Google Cloud, AWS, or on-premises. So you can have this tool. This tool can support deployments across all these platforms that we've discussed here. So again, reiterating, so for now we have these two services available in OCI. The support for logging analytics is coming. We can also make use of APM, but then in the context of MySQL, we have monitoring diagnostics, which is more of tactical in nature for your day-to-day requirements. You can make use of the database management service, which allows you to start from the fleet and then drill down to a single database and then do deep observability. And then if you want to retain the data for more than or maybe more than 2 years, so we retain the data for 25 months. We can make use of AI ops through ops insights. We have capabilities like SQL insights, and you can do smart capacity planning as well. So now the difference between monitoring and observability. So monitoring tells you what, and then observability tells you why. So we need to go deep. Monitoring essentially is a set of predefined alerts, metrics. So you get to know what is happening, but then why is it happening is where you need to look at observability. It is more of an exploratory tool wherein it gives you the root cause analysis and also it gives you dynamic dashboards. So for monitoring, this is the interface that we have. For database management, you have a unified fleet view of all your MySQL instances running. You can have key metrics. You have the summary for the resource consumption from a CPU, memory, and storage IOPS perspective. And from here, you can drill down to the individual metrics. You can add more metrics as you want. The default set of metrics kind of compares between the operating system as well as the MySQL metrics from a connection, CPU usage, memory, and all that. But if you want to do deep dive, you can add more metrics to this chart as well. Now here is like a real-time use case that we kind of did. We did this in our labs, and we kind of reproduced how you can actually kind of see any kind of active and current connections that are available at any point in the system. So essentially, you would see that if I am a programmer that has done bad coding and I've opened a lot of connections, I would see connection leakage, which is reported by the current connections. Ideally, I want to be the purple line wherein I open and close the connections as quickly as possible. But then this would clearly indicate there is a problem there. I don't want to be the blue guy, but I want to be the purple guy, and I can talk to my developers to fine-tune the connection, or maybe fine-tune the connection pulling mechanism at the middle tier. So then we go to observability. So we need to know, okay, where exactly the problem is. So we started with query tuning. I'm kind of doing an inverse wherein, okay, I had a problem with the connection. Maybe that's sorted out. Now I have a problem with the query. What do? I need to go to Performance Hub. If you've used MEM, it is the query analyzer, which is called as Performance Hub now. So you can get all the details about the query. You can drill down to a SQL text. It's basically an aggregation of query content with a lot of performance metrics in there. So you can actually see that this is one example wherein we spoke about key metrics, the 9 key metrics. So here you would see there are 2 SQLs that are highlighted here. One examined a lot many rows, but it only sent 21,000 rows, and the second one examined the same number of rows that was sent back to the client. So we need to investigate why the first one took, or why did you examine a lot many number of rows, maybe an index is missing or something of that sort. And that's where you can drill down to the query, you can get the details, and all the 9 essential query metrics that we were talking about in the concept section is captured in here in the performance hub section, and then you can actually drill down and see where exactly the problem is, and that's where you have deep observability. Now we have done everything possible. I've been tuning the system on an ongoing basis. So the question is like, okay, I'm seeing slow degradation in performance over a period of time. So maybe the question is like, is it time to scale? Do I do capacity planning or do I do forecasting? So how do I come up with a readiness check? So this is where you have a readiness check in terms of, I keep checking, is the response time too high? Are the slow queries optimized? And do I have any access pattern issues? Do I have to review them or optimize them? And has the data been deleted or archived, or is the right partitioning strategy in place? If all of them are checked, then move on to the second section to look at whether I have CPU utilization greater than 80%, or maybe if the memory is being utilized properly, or I have a storage IOPS related issue. So then if any of these two things are kind of an indicator, or maybe that is the problem area, then it is time to think about forecasting and capacity planning. But then right before capacity planning, we also need to look at this baseline readiness, and that should be on an ongoing basis. Now that's where we have this predictive insight from a SQL perspective, which is called as a SQL insights, where you can correlate the SQL degradation over a period of time. You can compare them across databases. You can trend and forecast the metrics seasonality via custom analytics. We'll talk about the custom analytics or the custom dashboard, how you could create that. And then maybe the workload changes are because of data access pattern, and this query was performing well and it degraded over a period of time. So you have not really improved your query tuning, or you're still in the query tuning cycle, and it's not time yet for you to scale up or go increase your capacity. So this is another way to do query insights, which is an exploratory query-driven interface, where it's like SQL that you can bring in, but you don't need to really be a SQL expert. All the essential performance schema metrics are being captured in this area. And if you know the key metrics that we were talking about and the key areas that you need to actually look at, you can easily build widgets or maybe create charts or pie charts, and then get informations like inefficient queries over a period of time. Maybe what is my query load from a SQL perspective? What is my query load from a user perspective? Who are my top users? What is my top SQL? And maybe I can also look at top queries with no indexes, top queries with disk sorts. All these problem areas that we were discussing earlier comes more effective when you use this kind of tool. And then once that is done, you go beyond the guesswork. You have all the data that you need, the CPU metrics, the storage metrics, the memory metrics, and then using this data, you can identify whether it is time yet for you to do capacity planning. Maybe you might see a lot of CPU spike over a period of time. You go back to SQL Insights and see if you have tuned your SQL properly, and then come back and see if you can perform capacity planning effectively. So with that, I'll kind of summarize it here. We started with the right question in terms of, okay, why is my performance lagging? What is a slow query? What does it mean to you? How can I optimize it? I can do that in two ways. One is the direct optimization. The other one is the indirect optimization, wherein I look at the query access pattern, directly access the query, or maybe indirectly access the query, and then look at the load from a concurrency standpoint. Is it really required for me to scale up the CPU or maybe throw in more hardware? If not, what are the alternatives? So that's where I would lean into observability and monitoring, wherein you monitor it on a regular basis and then do observability and make use of the right tooling at the right time and decide whether it is time for you to do capacity planning or maybe to do SQL tuning, or you decide what you need to do. So with that, I will also leave you some resources. We have live labs wherein you can practice at your pace. This tool that we discussed is something that you could use for heatwave deployments as well as on-premises deployments. We have live labs for both, and we have good YouTube content videos if you want to know how to get started with this.